So what you're seeing here is the CAD for our project. We've got a tennis ball modeled in here. The flywheel spins either in or out depending on the situation, and these belts here allow for the ball to be both funneled but then also received and taken in. These individual notches allow for us to adjust the tension of that to accommodate the potential need to do so for the motors, and then we swivel about on this pivot with mounting space for the camera on top.
Now on to the electronics design. The electronics are all controlled by a Raspberry Pi Zero with two LN232 motor drivers controlling the 12-volt motors. There are two separate power systems. A 5-volt battery powers the Raspberry Pi, the camera, and the sensor suite, and the 12-volt battery pack powers the 5 DC motors via the motor driver. Each motor driver can control only two independent motors, so the motors for the paddle system are connected in parallel to a single driver. The drive wheels allow the system to rotate 360 degrees, both clockwise and counterclockwise, around a fixed point, so that the camera can target a potentially infinite number of players, limited only by the distance at which the Haar cascade can identify their eyes.
Here is a demonstration of our robot. Following the steps of the code, the Pi camera is going to start looking for an image. As you can see, it found one, it's centered on the eyes, and spun the flywheel to launch the ball. Now we're going to wait for the limit switch to be activated or for the timeout to occur. This is how we know the ball's back. Once that occurs, we are going to run around and continue seeking, rotating around and around until we find another pair of eyes to lock onto. Center again, launch the flywheel, and send the ball flying out.